Hey everyone. So today we're just going to be practicing with this worksheet on proving identities. And, it should be noted that this is kind of challenging. This is something that you might need to attempt a certain problem multiple times with different, strategies. But I'm going to go through a lot of these with kind of a number of different videos just so that we can see it being worked out a number of different times until we can potentially see some of the patterns in the logic and we start feeling more comfortable to attempt them on our own. So I'm going to go through these 4 problems here and potentially even do kind of another 4 after that. But goal is just to see how I'm thinking about them and then start kind of those gears moving in your own mind so that you can feel more comfortable attempting them on your own. So for problem 1, this is a case where I probably want more things to be in terms of sine and cosine. So I'm going to change secant of x and tangent of x and write them in terms of sine and cosine. So secant of x is 1 over cosine. I know that tangent is sine over cosine. And this is still being multiplied by sine here. And this needs to be proven to equal 1 over secant of x. So this is where I kind of currently stand. I'm going to simplify this term here so that it just reads as sine squared x over cosine x. My denominators are the same, which is nice. That means that I can squish this fraction together at this point. So now I'm here, and if I do a little sidebar, one of our Pythagorean identities is that sine squared x plus cosine squared x equals 1. And what I'm hoping to do is use this, or try to get it to look like this kind of expression of 1 minus sine squared x, because I want to be able to replace this with a single trig function and not have 2 terms. So looking at sine squared x plus cosine squared x equals 1, which is just a Pythagorean identity, if I subtract sine squared x from both sides here, then I'm going to get that cosine squared x actually equals 1 minus cosine squared x. 1 minus sine squared x. And that is actually in my expression, which means I can rewrite this now as cosine squared x over cosine of x equals 1 over secant of x. Using that exponent, because cosine squared x is really cosine of x times cosine of x, I can just get rid of that exponent and cross out this denominator. So now I have, again, I haven't changed my left-hand side, but my right-hand side is all the way down to cosine of x equals 1 over secant of x. And then to take this final step, because I'm at a statement really that's true, but normally I kind of, hit somebody over the head with kind of the logic, and I say, okay, cosine of x is really 1 over secant of x. So I've adjusted my left-hand side all the way up until it explicitly equals my right-hand side, and then I'm going to be done, okay? So I needed a Pythagorean identity to get from there to there, and then I also needed a reciprocal identity to get from cosine of x to secant of x. All right, let's take a look at our next problem. I saw this done multiple ways in class, which is true of identities. Obviously, we have different ways of manipulating an expression. But I use what's called like the Kit Kat bar strategy, which is, very much copyrighted by me. I don't think anybody else is of the same level calling it that. But I can, break this numerator in half. So what this ends up giving me is 1 over sine of x plus cosine of x over sine of x. And I'm trying to see, okay, did that get me any closer to proving that this equals cosecant of x plus cotan of x? So to prove it to yourself that I could take this first step, I would recommend that you kind of look about going in this direction right? If the denominators are the same, then I could smush them together. But it also means that if they're written as a single denominator, that I could also break them in half just as easily. And the reason why this is helpful in this case is that 1 divided by sine of x is cosecant of x, and cosine of x over sine of x is cotangent of x. So I was trying to prove that this equals cosecant x plus cotan x, and basically I've already done it in that step. So I snapped them in half, and then I used a reciprocal identity here. So this was a reciprocal identity here. And then this is a, I think it's called a cotangent identity on your, or cotangent statement on your kind of cheat sheet that's attached also, okay? But that left side equals right-hand side, kind of good to move on from there. All right, looks like we have a lot of fractions to contend with here. So let's see what I can do. I'm going to switch stuff over to sine and cosine. So this is now going to be 1 over cosine of x. And I'm going to switch my thetas to x's just because I'm already there. This is sine of x over cosine of x plus cosine of x over sine of x. So this is where I am. I took my numerator secant sine and turned it into 1 over cosine sine. I took my denominator with the tangent and cotangent and wrote it as sine over cosine plus cosine over sine. And we might be thinking, it definitely looks more complicated, but we're going to see if I can do some simplification here. My numerator I could just write as sine x over cosine x. And then I've still got this larger denominator here to deal with. And in order to deal with that denominator, and this comes up a lot, I need the denominators to be the same. So for this term on the left, I'm actually going to multiply it by sine over sine. And for this term on the right, I'm going to multiply it by cosine over cosine. All right, so this is now going to become sine squared x over, I might just write kind of the final statement here and see if you can get there with me. All right, so my denominator became sine x cosine x for that entire statement. And then my numerators were sine squared and cosine squared. So I was able to combine those into sine squared plus cosine squared. Before I do any kind of flipping or simplifying there, I'm probably going to say that I can write this full expression. I'm just going to use some of this space down here to do that. This can also be written as sine x over cosine x times, this is sine x cosine x over sine squared x plus cosine squared x is just 1. Okay, that's a Pythagorean identity. And I'm trying to prove that this equals sine squared x. So what I did was, instead of dividing by that fraction, I multiplied by the reciprocal. And then I also made note of the fact that sine squared x plus cosine squared x was 1. And this is going to kind of help me out. So I'm actually pretty close at this point because I can cross out cosine of x here. And I end up with sine of x times sine of x equals sine squared x, which is true. Just to kind of go that full distance, I say sine squared x equals sine squared x, which was my final statement, proven to be true that the left-hand side equals the right-hand side, and I can leave it at that. All right, question 4 here. Going to, again, try to switch these over into sines and cosines. So this first term on the left, secant theta divided by cosine of theta, can actually be changed to 1 over cosine squared theta, because secant is 1 over cosine. So I have two cosines really in the bottom being multiplied together. And I have minus. This looks like sine over cosine divided by cotangent is cosine over sine. Trying to prove that this equals 1. I don't love that I have this stacked fraction. So I'm going to say I'm going to keep this term the same. But here I'm going to multiply by the reciprocal. So I have 1 over cosine, and I'll add back my thetas because I kind of got rid of them for no reason. Instead of dividing by cosine over sine, I'm going to multiply by sine over cosine. Trying to prove that this equals 1. So this becomes, I have 1 minus cosine squared theta minus sine squared theta over cosine squared theta equals 1. My denominators are the same, so I'm going to combine them. 1 minus sine squared theta over cosine squared theta. And then using a Pythagorean identity, and I think we kind of already came across this, so if I scroll up a little bit and I follow my highlighter on the top of the page, I have that cosine squared x equals 1 minus sine squared x. So that's actually my numerator here, which means I can rewrite this statement as cosine squared theta over cosine squared theta equals 1, which is true. So I have 1 equals 1. Final statement. So that's our first 4. Honestly, that has basically all the skills that we need with fraction work, Pythagorean adjustments, reciprocals. It's all kind of here. So at this point, we just kind of need to watch a lot of these, practice a lot of these, and see if we can start trying to get them independently, but I fully know that it's a struggle. I'll do another video for 5 through 8, and we'll see